Okay, in 1989, 44% of a country's population was on a weight loss diet. And then in 1997, only 12% of the same country's population was on a weight loss diet. So if we measure time in years since 1987, we're going to translate that information into 2 points. Okay, so we've got 1989, 44%, 1997, 12%. So 1989, how many years after 1987 is that? 2. So I've got 2 comma 44. That's one of my points. And then my other point, 1997, 10 comma 12. All right, so I've translated that information to 2 points. How do you find the slope of a line through 2 points? Yeah, 12 minus 44. So you subtract the y coordinates over 10 minus 2, subtract the x coordinates. What are the units on the 12 and the 44%? So I'm just going to write this down. That's percent, because it's going to help me answer the next question if I keep my units here. And what are my units on 10 and 2? Years. Okay, so when I actually subtract, I get negative 32 over 8. Percent is my units on the top, and years are my units on the bottom. Negative 32 over 8, does that reduce? Negative 4. Yeah. So this becomes negative 4% per 1 year, right? Because when you reduce that, it becomes negative 4 over 1. So negative 4% per year. So let's interpret that slope in the context of this story. What does that mean? Every how many years? One year. Yeah. Yeah. Each year, 4% fewer people in this country are on a diet. So the percentage of people on a diet is decreasing by 4% each year. Okay. So where did my negative sign go? Why didn't I write a negative sign anywhere in this sentence? Because I used the word decreasing, right? The negative sign indicates the decreasing. So if I wrote decreasing by negative 4%, it's like just like using a double negative in the English language, and it ends up meaning the opposite, right? So you can either say changing by negative 4% or decreasing by 4%, but don't use both. All right, so I now have the slope, and I want to write an equation of this line that models the percentage of adults on diets X years after 1987. So the equation in slope-intercept form is y equals mx plus b. And I now know what m is, so I'm going to put that in. It's negative 4. And the only other thing I need is b, the y-intercept. Anyone know how to figure it out? Yeah. Plug in one of my points. Which point? Sure, yeah, you could do either one. You just tend to pick the one that makes your arithmetic easier. So yeah, I like 10 for x because multiplying by 10 is easy. So I'm going to put in 10 for x and 12 for y. So that says that 12 equals negative 40 plus b. Add 40 to both sides, and you get b is 52. Okay, so my final equation is going to be y equals negative 4x plus 52. All right, what is the significance of the y-intercept in the context of this story? Right, the y-intercept, what is the y-intercept? 0, 52. Thank you for giving me both coordinates. So 52 is the y-intercept, which means that's where it touches the y-axis, right? But that point has two coordinates, an x-coordinate of 0 and a y-coordinate of 52. So in the context of this story, what does the 0 represent? Yeah. You got it. Yep. In 1987, that's the 0 years after 1987, 52% of the population was on a diet. All right, now I'm just going to do this a little bit differently. I'm going to find an alternative equation of the line. It's going to be equivalent to the first, it just looks a little bit different. And we're going to use y minus y1 equals m times x minus x1. And again, I know m, right, was -4, so I'm just going to put that in. And then the next thing I'm going to do is replace x1 and y1 with one of my points. Either point, doesn't matter, or any point that you have. So I have 10 for x and 12 for y, so I'll do y minus 12 is -4 times x minus 10. That's called the point slope form. It's called point slope because I used a point and the slope to make it. All right, now I'm just going to simplify this guy that I just wrote. I'm going to simplify it a little bit and show you that's the same thing as y equals -4x plus 52. So I'm just going to recopy it on the next page here. Y minus 12 is -4 times x minus 10. Okay, I'm going to distribute the -4. So I have y minus 12 is -4x plus 40, because -4 times -10 is positive 40. Then add 12 to both sides, and I get y equals -4x plus 52. So that is just to show you that those two forms for the equation of a line are actually equivalent. They're the same. So you can use whichever one you like, right? Unless a problem specifically asks you to use one or the other, but typically you just pick the one you like and use that. Okay, use your slope-intercept equation. That's y equals -4x plus 52 to predict the percentage of adults on a diet in the year 2000. So first, is years x or y? I heard one person. X. Yeah, years is x. Years since 1987 is x. So how many years after 1987 is 2000? 23, yes. No, 13. Yeah. Okay, so the year 2000 corresponds to x equals 13. So I'm going to go ahead and put a 13 in for x. So we end up with y equals 4 times 13 is 52. And I get 0. Y equals 0. So 0% of adults will be on a diet in the year 2000. Yeah. In what year was 50% of the country's population on a weight loss diet? Well, which is percentage, x or y? Y. So I'm going to write down my equation. Y equals -4x plus 52 and make the y a 50. And then I just have to solve for the x to figure out when. Okay, so I'm going to start by subtracting 52 from both sides. So I get -2x equals -4x. Divide both sides by -4. And I get x equals 1/2. So what year is that going to happen? 1987 and a half, halfway through 1987. Okay. And that number kind of makes sense because we started at 52%. It shouldn't take us that long to get to 50%, given that it changes by 4% every year. So if we assumed that the percentage of adults on a diet declined by exactly 4% each year, the scatter plot of the data would look like this, right? We'd start at 52 and we'd subtract 4 and get 48, subtract 4 and get 44, subtract 4 and get 40, etc., right? Just keep subtracting exactly 4, and you just would end up with a scatter plot like this that looks like a perfect line. You can draw a line right through all of those points. Okay, so that perfect line is y equals negative 4x plus 52. We found it earlier. And it would pass through every data point perfectly. We call that a perfect correlation. But usually when you're modeling real-world variables, we get data and a scatter plot more like this guy, right? So in this case, all the data don't fall on the same line, but they do all sort of cluster around a line. So even if the correlation isn't perfect, it does look like there's some line that they're all gathered around. So here's the real world data with a line drawn through the 2 data points we were given, 2, 44 and 10, 12. Okay. So choose any other 2 points from the data and draw a line through them. So let's choose 338 and 534, right? Pick 2 random points, connect them with a line, and we get a pretty different looking line than the one that connected the 2 points that we started with. Or I could pick 626 and 724, right? Another totally different looking line from either of the 2 I have already. So if every person in the class picked their own 2 points and drew a line through them, and we put them all on the same picture, we'd get something like this. We have a crazy mess, jumble of lines, right? So how do we decide which of all these lines is the best fit for all the data? Yeah, we have something called the line of best fit. For now, we let a calculator or computer do it. So we let a calculator or computer decide which line is the best line to model all of the data, not just 2 points from the data, but all of it. So if you take a statistics or a calculus course, you're going to be able to do this yourself. But for now, we let a computer do it. And in project 3, which is coming up, you'll learn how to have GeoGebra find the regression line for you. But the equation for the best fit line, also known as the regression line that's on this picture here, is y equals negative 4.3x plus 53.95. It's not exactly the line we found before, because we just found exactly the line through 244 and 1012, right? Which turned out not to be the most representative line for all the data. So we come up with, or your calculator or computer will come up with a number called a correlation coefficient. It measures how well the best fit line or the regression line fits the data. The correlation coefficient is always a number between -1 and 1. We call it R, correlation coefficient. When R equals 1, that means an exact linear fit. Your best fit line passes through every data point and has a positive slope. Perfect correlation. If R equals -1, this is also a perfect correlation. Your best fit line passes through every data point, but it has a negative slope. If R is between 0 and 1, there's a positive correlation, which means as X values increase, so do the Y values. But the fit is not exact. If R is negative, if you get a negative value for R, that's called a negative correlation. Again, it means that As the x values increase, the y values decrease this time, and the fit is not exact. So we have a negative sloped best fit line. And when r is 0, that means there is no correlation. So the data has no tendency towards being a line. It's just a completely random shot of points on the plane. So a regression line will give very poor predictions. So the closer you are to 1 or -1, the better the fit. Okay. And positive and negative just tell you whether your regression line has positive or negative slope. Okay, I'm going to let you play around for a bit.